Hi and welcome back to this video tutorial series on Postgres clustering, and in this video we're now going to start actually making Postgres run, doing stuff to it, accessing it, and learning some of the basics of setting up Postgres. Now some of you have probably already done this, you've already started up Postgres and perhaps you already know how to use it as a single instance, and that's fine, but in this video we will cover the demo app, the test app that I've written to kind of demonstrate what happens during failover, and we'll also see some of the parameters that you need to consider setting before you start running Postgres in production. So let's sort of move on and kind of ask ourselves a question: how much actually happens when we first install Postgres, and how much do we have to configure afterwards? Now the good news is that most of Postgres is set up sort of by default. The parameters that it uses by default are mostly okay. There's just a handful of things that we will probably need to change when we use this in production. So first of all, we've already seen this in our Vagrant file, but in terms of installing Postgres, it's going to be in most of the package managers for, you know, Ubuntu, Debian, Red Hat, etc. But obviously you might be on a distribution that doesn't have it, in which case you'll need to build it from source, which I won't cover in this video. But it's just fairly standard sudo apt install PostgreSQL, and in some ways, in most cases, you probably want to specify the version that you need. Now it is common for a major distribution, let's say Ubuntu 22.04 for example, to actually pin that release of Ubuntu to a major version of Postgres. So for example, Ubuntu 22.04 uses Postgres 14, version 14, whereas the latest version of Debian as of this time is 13. There aren't many differences for the purposes of this video between 13 and 14, but just be aware that there are different major versions. And so if you're trying to use a very new feature and it's not working, then just perhaps check whether the version you're running is the version that you think you're running. Just because version 14 and 15 have been out for a year now doesn't mean that they will be the ones that you get from your package manager. So you can use either of these forms. You can add the -13. The star is just to say there's a note, and that's not part of the command. But that's all we have to do, and that was included already in our Vagrant file, which I'll show you again in a second. Now the two main configuration files that you'll be working with in Debian and in Ubuntu, this is the default location. It might be the same in other distributions, it might not, so you'll just need to check that. But you'll notice that we have etc, whatever you call it, PostgreSQL, and then the major version of PostgreSQL. So in this case, in Ubuntu it would be 14, in Debian it would be 13. Then the name of the cluster, we talked about clusters in the last video, but by default the cluster is called main. And then postgresql.conf is a very long file with lots and lots of parameters in it, so most of the parameters we set are going to be in there. And additionally, Postgres_HBA is about access control. So this is the file that defines the rules that say who is allowed to connect, from where, to which database, using which user, from which IP address, do they need to use SSL or not, etc. And we'll look at some of the details of that in a second when we connect up our test app. Obviously the default locations might be different, but for now these are the two files that you need to remember. And then the data is stored in a similar format, but notice that the data is in var_lib and not in etc. So var_lib PostgreSQL, this part is actually the default home directory for Postgres. So confusingly the user is called Postgres, those 8 letters, whereas the directory is PostgreSQL. So just be careful of that. If you start getting confused, that might be why. So var_lib PostgreSQL is the home directory, and then under that home directory again major version and the cluster name. So just as a reminder, we can have multiple major versions installed, and we can have multiple clusters under those, and they will all be given separate directories for the data. So for example, in Ubuntu, var lib postgresql 14/main is what you'll get by default. In Debian, you'll get 13, unless they've updated it recently. One thing just to note at this point is you should consider, if you're using this in production, using an SSD, a high caliber, high spec disk to put your Postgres data onto. There's a couple of reasons for that, really. Obviously, the more that you have on a single disk, the more access that disk has to share. So if you have the operating system and your database on there, then all of that data I/O is being shared between all of the things that the operating system is trying to do, as well as everything that Postgres is trying to do. So in our cloud versions, in our Azure instances, we have added an additional 16 gig disk. Our databases aren't very big, and that 16 gig disk is mounted, so there's a whole load of steps you need to do there, but then we've mounted that into /SQL data, and then we've reconfigured PostgreSQL to point to that external disk. It's not really in scope for what we're talking about here, but it is something that you should consider. Another reason why it's a good idea to have it on a separate disk is if you completely screw up the OS and the server that it's running on, what you can obviously do is detach that disk and attach it to a new VM, and you can get the data back, hopefully, as long as you do it quickly enough, and get it up and running again quickly. So that's also a good idea. The executables are stored in a third location, so these are under user lib, and again there is a separate folder for each version. Obviously not a separate folder for each cluster, because the clusters will all use the same tools, and these are things like the psql command line tool, all of your pg dump and pg start and pg control and all the rest of it. There's a whole load of them in there. It's worth writing this down, remembering where that is, or at least finding out where it is, because when we set up rep manager later on, we need to point rep manager to the correct location for these. There is actually a bug in the rep manager Ubuntu package where it doesn't work correctly, it doesn't find the right executables, and if you try and use rep manager on Ubuntu without overriding these locations, then it just doesn't work and you screw up your system. So be warned that we will need to use these later. And again, this is a default location in Debian and on Ubuntu. It might be different on your distribution. One thing worth mentioning at this point, again mentioned it in a previous video, that obviously with systemd you have services that restart, but you can also reload them. So reload tends to leave the service running, but it instructs it to reload the configuration, whereas restart will stop the service and start it up again. Now some of the parameters can be modified and you can call a reload, so without any downtime you can get that extra functionality. A good example is the pghba.conf file for access. If you want to add access to a new subnet or a new database or whatever, you can modify that file, you can call reload, and you don't get any downtime, you don't get any broken connections. However, certain things, if you attach it to different network interfaces and things like that, then it's obviously going to need to restart, because it's going to need to rebind. So some things require restart, some will require reload. They're kind of documented depending on where you look. Sometimes it mentions it quite obviously, saying all you have to do is do a reload. Sometimes you might need to dig around a little bit, but obviously worst case is if you restart, it will always reload it. And that's one of the reasons why it can be important to try and do some planning before you start running these things in production, because if there's a parameter that you can't change without restarting, then you're immediately going to create a failover scenario or a downtime scenario if you haven't got that set to the right value right from day one. So trying to think about these things a little bit before you start going is can be really helpful. And we're going to look at some of the parameters that we're going to need to adjust. Now I will go through this again in seconds with a real example of HBA.conf, but this is probably the biggest area where you're going to get confused and you're going to find problems trying to access databases. Rep manager can't access the database, barman can't access the database, you can't log into it, and it takes a little bit of time just to get your head around it, but it is actually quite simple to understand once it clicks, and then you won't have any problems in the future. But if you ever get any issues with, you know, permission denied and stuff like that, it's very likely that either your rule in hba.conf is wrong or it's in the wrong order. And the order is really, really important to understand, because rules are evaluated in order from top to bottom. But the important part, that might be kind of obvious, the important part is the first rule that matches the location. Is it on a remote host, is it local, is it on a Unix pipe, etc. The target database, the target user, and the source IP address. The first rule that matches will dictate whether that connection is allowed or not. So what it won't do is you won't get to say, well, I've matched all of these, and let's say it requires a password and there's no password. It will not evaluate the rule afterwards that says, oh, but you can also trust it as well. It's going to hit that first one, say I've matched it on this one, it requires a password. If there is no password, I'm going to say no, and that's it. The execution stops. So what that generally means, if you've seen this before in other scenarios, which you might, it means you need to put the most specific rules at the top, the ones that match the most items at the top, and then work down to your most general rules. And then sometimes what people would do is they'll also add a final rule that kind of blocks everybody else that hasn't matched a rule. You don't really need that, because if it hasn't matched a rule, it's not going to let you in anyway. But yeah, sometimes people kind of do that. So more specific ones at the top and more general ones at the bottom. And one thing just to point out, particularly once you see the format, I'll show you in a second, it might kind of seem quite obvious what's going on, but just bear in mind that local doesn't mean that it's a connection made from the local machine. It means it's a connection made over a Unix socket from the local machine. So one of the scenarios is using Rep Manager. Rep Manager uses SSH to log into another database server. That connection will not appear as local because it's made over SSH. It will appear as a remote IP address, or possibly a local IP address, but it will not use the Unix socket. So again, if you're having problems with Rep Manager connecting, there's a good chance that you've assumed that local means I'm logging in from the local machine rather than I'm logging in using a Unix socket. Don't worry, we'll see examples of all of these. And as I just said earlier, you can reload Postgres when you change this file rather than restarting, so that means you're not going to have any kind of downtime. Now what we're going to do is, and again I'll show you this in a second, where you get a default HBA.conf, which isn't particularly useful. There's one rule in there that's useful, and there are a load of comments which are kind of handy to read when you first open it, but we're going to sort of clean that all out and really add things back in as we go along. And that's just because we want to make sure that we understand why each of the rules is there, rather than using some default rules that might be useful for us, but we want to sort of add them all back in, which we're going to do through these set of videos. And another thing to bear in mind is when you create this config file, it should be identical on each of your servers. Because of this, again, getting out of the mindset of this is the primary server and maybe Barman is backing up this server and not any of the others. The point is we need to be flexible enough to fail over to different servers. Maybe server 2 becomes the primary, maybe server 3 becomes the primary, and as soon as that happens, the direction of everything is going to change. All of a sudden, that connection that's pulling data from 1 to 3 is going to be pulling data from 3 back to 1. And Barman's not going to be getting it from Postgres 1 anymore, it's going to get it from Postgres 2 or whatever. So by making sure that the config works and it's the same on every machine, you know that when you fail over, you're not going to suddenly have a failed connection from something. And that could be from your app, it could be from Barman, it could be from Rep Manager, it could be any of the replication or backup connections. So we kind of mentioned this briefly. It's not particularly related to the tutorial, but we will see it because we need to get our test application to work. But obviously one of the things that you will need to give access to are the services, the web apps, whatever it is that needs to access the database. Now, these will depend on your infrastructure, and I don't want to talk too much about this because it's not really relevant to what we're talking about here. But just as a good practice is we lock stuff down using private virtual networks so that the outside world can't access your database server ever, because it won't be bound to a public IP address. Or if it is, it's only locked down to specific IP addresses like your office or your work PC or whatever. So you can then lock down as tightly as you can to say, for example, something that we've done. We have a set of microservices. They are on a virtual network. We have a set of Postgres servers, which are on a different virtual network. We've peered those two networks together, which means we can lock down access to our database servers to that other virtual network. So the ability of anyone else to access it accidentally is very, very small. Obviously, you could duplicate any of the functionality for different subnets. You might have multiple subnets for microservices, etc. But you can add a different rule for each one of them. So you don't have to try and capture all of it in one line. In some cases, it makes much more sense to say, here's one for that subnet, here's another one for that subnet, etc. And if you look at the docs for pghba.conf on the Postgres documentation site, there's some pretty cool features. For example, you can have host, which just says any host at this IP address, but you can also say SSL host, or it might be host SSL, can't remember, and that says that you can only log in from that host if you're using SSL, and if you're not, then the connection is denied. So there's a few cool little things like that which you can look at when you have time. We will then look at in a second, when I open up this test app, show you how it works. postgresql.conf, and again, this is the big file, loads and loads and loads of parameters in there. Most of them you won't care about. Most of them are fine by default. Some of them are only relevant in some scenarios, so don't worry too much about the fact there are so many parameters in there. Most of them are commented as well, which you'll see in a second, so they kind of explain what they're doing. And there are about 500 last time I looked, about 500 different parameters in there that you can play around with. Some of them will need to be set, which again we'll look at the list in a second. So at this point, I'm just going to pop out of the presentation here, because we will be looking at some of these, but I'm going to come back to these in a second. And I just want to introduce you to our test application. Now, I have just run up Postgres 1 using Vagrant. So we talked about Vagrant last time. This will have installed PostgreSQL, and by default that installation will run PostgreSQL as well. So that's all there. And as I mentioned before, if you do Vagrant SSH, you can log into that server that's running. But I haven't done anything on this server yet other than run it up. So it's installed Postgres, it's got its IP addresses and stuff like that. But otherwise we've done nothing. Now, this is our test application. It will be on the GitHub link, so you can get the source code for it. It's a .NET application, MVC, running in Visual Studio. Now, this is using Razor Pages, but don't worry too much about the application. The basic idea is it's going to run up. It's got a few pages where I've basically designed it to have a single database table called books. And then there are a couple of pages to add a book, delete a book, update a book, etc. So nothing really too crazy. The idea of the app is purely to demonstrate how all of these different scenarios work. So at the minute, you can see I've put in the IP address of the Postgres 1 server, which is .201. I've also added separate connection strings for the same server, PG1, PG2, and PG3. The reason I've added these, which you'll see in a minute once we've got this working, is to allow us to actually see what each of those servers is doing once we do a failover. So will it still let us update something? Will it still let us read something? Is the server still running, etc.? So if I just run this for a second, the way this works, the reason I've knocked it up in .NET Core is because we can create a database from the application. I'll just show you very briefly how that looks. When we access this database connection, it's called a context in Entity Framework, then you can see here this one little line says if the database hasn't been created, make sure that it's created all of these tables. So this is like a table called books, which is one or more books or zero or more books. So this will get created automatically, and it just saves us playing around trying to do all of that ourselves manually. So that's all cool. But let's just run this up a second, and hopefully it'll come up in the same screen. And the first thing that happen you'll see is it will throw an error. Okay, now if we look at this, we can say, right, failed to connect to 192.168.56.201.5432. 5432 is the default port for PostgreSQL. So if I just look at the details for this, there's a timeout during connection attempt. Now I happen to know why there is a timeout, but what I want just to show you is we've got something here. It's trying to connect, but it's failing. Now the reason it's failing, if we go into our Vagrant box, which is here, we're going to need to log in as the Postgres user. And the reason we do that is because the Postgres user is not sudo, and so we need to log into it in order to edit its configuration files for Postgres. We could do everything from here with we might be able to do, you know, sudo nano blah 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 blah, but I don't want to be typing sudo for everything. So instead, if I go into interactive mode as the user Postgres, which is, you know, that's just Linuxy stuff. Now what I'm going to do is I'm going to look inside the PostgreSQL. So remember, this is Debian, so it's version 13. And if we go to that file that we mentioned earlier, postgres.conf, the first thing that I can find if I look down here, we got these various directories. Now they're fine. You might want to change them, but for the purposes of this video, the defaults are fine for me. But very close down here, this is the problem. By default, like all good database engines, it only listens on localhost. Now, in our case, I need it to listen on all addresses because my app is running on my desktop PC and this is running on a VM, so I'm going to need to listen on that. Now, I'm not worried about the port. I'm happy to leave all of that, but you can see here that some of them will comment saying if you change this, you will need to restart. And it also says if you change the listen addresses, you need to do a restart as well. So that's fine. Let's just exit that, and we will go back out because the Vagrant user is sudo service. We're going to restart that. Okay, so that's now restarted. It's now listening on all IP addresses. So let's hit our F5 again. Right, next error, no PGA HBA conf entry for host 192.168.56.1. Super helpful message because it's telling you all of the information that you might need for your rule, for your access rule. So it's telling you that the host you logged in from was this, which is my desktop PC's virtual IP address. The user you were trying to log in with was books, so that's just the one we set here, and SSL was off. Now at the minute I'm not bothered about SSL particularly, we'll talk about that in a second, but that's kind of giving me all the information I need. So okay, what it's telling me is although Postgres is listening on the interface, it's not letting me in. Now that's pretty cool because what it's saying is you don't, just by changing the listen address, you don't suddenly open yourself up to the entire world, which is pretty cool. But if we go back into here, and if instead of editing that, we go into our pghbaconf file, this is the default. So there's a whole load of documentation in it. And again, you can read that yourselves, but at the minute, I'm just going to get rid of most of that. And get down to here. Right, a couple of things we're going to do. So it's kind of nice leaving that there just to remind yourself which way around database and user are, so we could leave that there. What we're going to do is going to get rid of IPv6 because I don't have that enabled, and we don't have any replication. I don't really know why I added those in there, but let's just make it much simpler. We've got 2 rules at the minute, or 3 rules if we look at this one. This is the important default rule. So this says if you are the Postgres user on, if you're trying to access the Postgres user in the PostgreSQL database, and you're logged in as Postgres user on Ubuntu, then this means it will allow you straight in without needing a password. A little bit like a sudo thing. So you say, if I'm the Postgres user and I log into Postgres using the database Postgres user, confusingly, then it will let me in. That's just the kind of the safety net. If anything else goes wrong and you screw everything else up, this is the one that's going to let you in. So it's kind of cool to leave that one there. This rule is saying that if you are connecting via the Unix pipe, so if you're logged in to the Linux box here and you can access any database and any user, but because it's peer, it will only let you log in as whatever user you're logged into Linux with. So let's say you had another user called Books, or whatever I called it in here. We've got user ID Books. So if I created a Linux user called Books, then I'd be allowed to log in as Books to Postgres using the peer method. Now, we're probably not really going to use that because we don't actually have any users other than Postgres that are going to connect, so we don't need that rule. And what it then leaves us with is a normal, what I'd call a normal rule. MD5 is a password, an MD5 password format. But if you notice here, it's again locked down to a specific address, and it's the localhost address. So that's not going to be much use unless you have a very small system where you have the web app and the database on the same server. Then this might be useful. But in our case, we're not going to use this because we're logging in from another machine. So 192.168.56.1, that's the IP address of my host machine. And you must use CIDR format /32 in this case because it's just one IP address. If you do this, it will not error, but it will not work. So you need to use the CIDR. And like I say, you could also do multiple rules that might be very similar like this. That's fine because the top one will match 56.1 and the next one will match 56.2. So you don't need to try and, you know, merge them into a single rule here. But we've done that. We're going to do that. We're going to go back out to our Vagrant user, and this time, as it said before, my typing's not very good, sudo service PostgreSQL, we're going to reload it rather than restarting. Now that was so fast it almost looked like it didn't do anything, but if I now start it up again, hopefully it will connect. I think it will. Oh, password authentication, no, that's fine. There is a step I've forgotten here. So it's got through the PGHBA.conf rules, so it's now letting me in. Of course, the bit I haven't done yet is I'm trying to connect with a user ID and a password, but that user ID and password doesn't exist because it's a brand new server that I haven't done anything with yet. So again, let's go back in, log in as Postgres. Let's just clear this a second. So what we're going to do is we're going to use the PSQL command line. Now, because I'm logged in as Postgres, I don't actually need any arguments to it. But if I was, let's say, trying to log in as different user, capital U, I might be logging in as Books, you know, -d database name, all the rest of it. In this case, because I am the Postgres user, it will log me in automatically as Postgres, and I've got obviously all of the full permissions to do everything in a database, which is pretty cool. So that's quite nice. PSQL, you use that a lot. Another form, by the way, if you need to exit, you just do quit, not exit. Use a \\. It's like a meta command. The other thing that's that you'll find quite useful is you can also run a command directly from the command line without going into the interactive prompt. So if you just need to do something like, you know, create a checkpoint or whatever, you can just do it in there. But for us, we're just going to in fact, we could do that, couldn't we? Just do it here. Never quite sure if it works with double quotes and single quotes. We'll find out in a second. First thing I'm going to do is create user. Now, Postgres doesn't really have a concept of a user, so this is a bit misleading. It uses something called roles. So a user is also a role. But if you use create user instead of create role, it will automatically give the user the login privilege. So that's why I'm using create user rather than create role. If you use create role, you'd have to do create role and then you'd have to say with login. So it's just a bit of a shortcut. And our user is called books. And hopefully I'll remember how to do this. The password is books password, which is obviously fantastic. Always put semicolon just to make sure. Create user books password blah. Okay, and it's echoed back the response, which is just create role. So it's kind of saying, yeah, that's fine, I've done that. And then the next thing that we want to do is you want to create database owner books. Oh, I need the name of the database, would be useful. The database is also called books. Okay, bang. Right, so we've created a role and we've created a database. Now that we've done that, let's try again. Right, what I've got on the front page is we have 0 books in the store. So that's literally a query that's counting how many books in the books table. The fact that it's returning a number means that this app has created that table for us in here. So if we go back to here, we could do, I don't know if you can describe a table in Postgres. Let's see. Describe table. Yeah, I don't even know. No, did you describe tables? That if you, let's see, I'm used to doing this in MySQL. Use database books. Is that going to work? No, I don't think it will work in a non-interactive prompt anyway. So don't worry, it's created us a table in there. And if we go to the books list, obviously it's empty. Let's just create a new book, and we could do Moby Dick. Already did that before. Herman Melville. Not sure how to spell his name. Create. So if we go back to home, we can see we now have 1 book in the store. And if we look at the list of books, then it's in there. So that's pretty cool, right? We can delete it if we want. You sure we want to delete it? Delete it. We're back to not having anything in there. So that's all the test app's doing, really. The thing that's important here, or the reason that I've made this slightly different than usual, is you can see here that I have a link for each of our 3 Postgres servers. Now at the minute, Postgres 1 is the normal connection that we're using anyway, so that's obviously going to be the same. But PG2 and PG3 are not currently running because we haven't set them up yet. So if I click on that, after a few seconds, it's just going to time out and show me a big ugly error message on here. So that's fine. So that's the idea of this, is it's going to enable us to go onto the different servers at different points in time and say things like, well, if it shows me a list, that means it's allowing a read-only connection. But if I want to do something like delete and it says no, then that's going to be because it's only a read-only replica and not a primary database server. So that's why I've set up this app in the way that I've done it. But now that we've done that, if we just go through and look at some of these listen addresses we just looked at, so we would possibly need to change that depending on the scenario, but in all likelihood we're going to need to listen to its external IPs. Max connections is an important one to think about. Now there is the ability to pool connections. You can do that within your client. You can also do that with an application like PG Bouncer, and what that allows you to do is say, well, maybe I'll only make, I don't know, 50 connections to the database, but I will allow PG Bouncer to make 1,000 connections to a load of clients, because most of them won't be doing anything. So let's have a nice big connection pool, but let's not hit the database server itself with lots of connections. Obviously, you'll have to set that depending on your infrastructure and your architecture. Password encryption, it defaults to Scram SHA-256, but you've seen MD5 already. Now, if you change this, the existing passwords will not be re-encrypted. So just be mindful, if you've changed this at any point and passwords aren't working, there's a good chance you'll just need to set the password again. And then once you set the password again, it will be encrypted with a new format, and then it will work okay. If it is set to Scram SHA-256, it should be backwards compatible with MD5, so it should be fine to upgrade it. But if you downgrade it, then you might have problems with that. The SSL settings we'll look at in the next slide, but there are some default settings that Postgres gives you with a fake certificate, basically. So the SSL mechanism will work, but it obviously won't be trusted. And then there are a number of parameters. Again, I don't really want to go into too much detail at this point because it's possibly a bit of a distraction. But things like shared buffers is the amount of memory that the database is allowed to use for a number of different jobs, including maintenance and queries and cache tables and stuff like that. There are a number of articles you can find if you're interested about how to set that, what to set it to. They might say set it to 75% of your server's RAM, that kind of thing. But just again, be aware that before you go crazy into production with Postgres, there's certain things that are good to tune. Now, you can change these later. Some of them you can change with a reload and they'll be fine. Other ones might need a restart, so you might need to get your failover working if you want to be able to change some of these without taking the database offline for a short period while it does its job. So work memory, maintenance work memory. While log hints is really important because it effectively adds additional metadata to the log files so that recovery and stuff is able to use those to work out point in time and things like that. You can't enable that after the logs have started being created, so you want to switch that on right from the word go. While compression as well, we'll want to turn that on because it'll save you quite a lot of space and network size. And then the max WAL size and max WAL senders is down to the number of replicas you're going to have. So again, you don't need to go crazy with it, but make sure that you're going to have enough WAL senders, particularly when you're first having a play with it. What you don't want to do is get to the point where you're trying to create another replica, but you can't because there aren't enough senders or slots in order to actually create that replica. So make sure you've got a handful. You don't need loads, but you might want to set that to 10 or something like that. And then shared preload libraries is a section that basically says which extension libraries do you want to load when this Postgres starts up. So it'll be things like there's some statistics extensions, rep manager, things like that. So some of those will be added by the package. So when you use rep manager, it will automatically modify that parameter. But other ones like pgstat activity, I think, which is quite useful for debugging queries and stuff like that, it won't be added by default. You'll need to go in, add it, and of course you'll need to restart the service because this is actually an executable it's going to need to load. So there's a few little things there. Again, don't want to sort of get sidetracked on it, but just be mindful of a few of the things that you might need to think about. Now, when it comes to SSL, Postgres provides a working system because it will give you a certificate, so the actual setup will work, but obviously that certificate's not going to be trusted. So if you actually need to verify that SSL connection from your client, then it's not going to verify. So one of the things we'll look at a bit later on is things like SSL mode in the connection string. So you can set something like require, which says that if SSL isn't set up on the server, then the connection is going to fail. But that required doesn't do any verification. All it's going to do is get an SSL certificate. So it will encrypt the connection, but because it's not a trusted certificate, it won't stop a potential man-in-the-middle attack where somebody effectively verifies with the client and then proxies that connection and verifies to the server at the end. Then require is not going to give you that protection. Verify full will give you the protection, but your SSL cert will need to be trusted in order for that to happen. To be honest, it's pretty easy setting it up. If you have certificates, it's very easy. You just do your normal certificate and private key files. You point to them from the Postgres parameters and it kind of just works. So it's pretty easy to do, but there's some extra setup, of course, that you will need to do. You might be happy enough to use the snake oil certificate that you get by default, because if actually all of the connections run inside a private network and then you're not really that bothered about it, then you can use SSL or even non-SSL if you want, but you've got to just be careful that if you make any changes in the future and you start sending connections over untrusted networks, that in some ways you ideally need the server to require it for every connection, so that you don't accidentally make an external connection using non-SSL connections. So a little bit of playing around, not particularly relevant for the cluster setup, but it's just worth doing that. And we've already seen that. I showed you creating a database using PSQL, and I mentioned pgadmin before. I haven't shown you what it looks like yet, but again, you can just create stuff in there. It's just a GUI really. And as I showed you, it's common to create a database and a user with the same name, and the user is the owner of the database, and that just allows that user to do whatever it needs to do in that database, but it won't be allowed to do anything anywhere else. So that's all we're kind of looking for now. We've seen Postgres getting installed. It's just worth mentioning before we finish that in our example, I'm going to need to set up those same parameters on PG2 and PG3, because although we're going to replicate the database to those other servers, that replication won't replicate the server parameters. It will just replicate the data. So things like listening on all interfaces and any changes I might want to make to number of connections and things like that, I need to make sure, again, identical changes in every server. The only difference will ever be in configuration is things like rep manager has a name for the node, so that name's going to be different, PG1, PG2, PG3, whatever we want to call them. But in general, all of the other parameters should be identical across all the databases, because as I keep saying, you don't want to fail over to another database and then realize that something doesn't work because one of the parameters has not been set. So that's it for now. In the next video, we're going to be looking at Barman, which is the backup and recovery manager, and looking at some of your options that you have for creating databases in Postgres, and more specifically how we're going to automate most of that and set up Barman to do all of that in a really straightforward way. So I'll see you in the next video.